Hi everyone. We are going to continue on our chapter and quick guide notes about organic chemistry. We left off with alkanes, so I just kind of want to go through briefly, just review. When we talked about organic chemistry, remember we said that this was the chemistry of carbon. And specifically, it's really the relationships between carbon, oxygen, and hydrogen. Now, we said that there are three different types of hybridization states and geometries that we'll focus on with organic chemistry and organic compounds specifically. That's sp, which is linear, sp2, which was trigonal planar, and then of course there was also sp3, which was tetrahedral. Now we said that the sp3 tetrahedral would yield a more four single bonded carbon compound versus sp2, which would probably give us a double bond somewhere within that structure. And then we also have the sp, which is a linear, and more often than not we'll have some type of carbon triple bond in that. We last left off with alkanes, and we said that there were three different types of these carbon compounds. Actually, there are four types, but we'll really only focus on three types. Those four basic types were the alkanes, the alkenes, and the alkynes. And alkanes were the single bonds, the alkenes, E-N-E ending, were the double bonds, and then the Y-N-E were the alkynes, and that's the triple bond. Remember that fourth type was the aromatic carbon compounds, and we're not really going to focus on any of those, but the only one that we will probably see is benzene that we'll talk about. So alkanes, we call them saturated hydrocarbons, and we had this discussion already that they're saturated because we consider them to be saturated with hydrogen. So if I look at my formulas, alkanes are, a Lewis structure of an alkane is going to look like this. These are called structural formulas. It's really just kind of giving us a backbone of what's happening with the formula itself. They're not so much convenient in the fact that if you have a really long carbon chain, no one really wants to draw out all of these carbons and draw out the structural formula. So because we don't want to draw out the structural formula, we usually do a condensed version, and that condensed version will look more like this. So I have a carbon bonded to a carbon, and I always want to show in a condensed formula the true bond, that true backbone. So this is a carbon-carbon bond, and then the hydrogen bonds coming off of it are not as significant, so that's why I just write the H3 there. So I have a carbon-carbon bond here, and then that carbon is going to be attached to a carbon, and then I'd have the hydrogen coming off either side here, which I see here, and then that carbon will be attached to a carbon, hydrogen's coming off either end, and then that third carbon will be attached then to that fourth carbon, and then I know that it's attached to those three hydrogens there on the end. So these are two versions of condensed formulas. This would be the more condensed structural formula versus this is just a condensed formula. So a lot of times using a condensed formula is much easier than this structural formula here. Okay, so the first 10 members of the straight chain alkane series, there's all of the following names, including their boiling points as well. And there's one thing that we need to, I think, know just in terms of writing down, like how do we know it's methane, how do we know it's ethane, how do we know it's propane. So on the whiteboard, these are the following designations for labeling something as whether it's going to start with the prefix meth or eth or prop or bute. So if I have one carbon, I'm going to think about it with meth. So if it's, if I think about CH4, that's one carbon, it has the hydrogens around it, I would call that methane. If I have two carbons and they're bonded singly, I know that that's a single bond ends in the A and E, and so I'm going to call that ethane. So eth will be our prefix for two. Prop is going to be our prefix if we have three carbons present. Bute is going to be our prefix if we have four. Pent will be five. Pretty much pent through deca, through dec, is going to be the same thing as like the molecular compound naming. So those rules, I think, from pent to deca shouldn't be any type of surprise to you. I think the really only new ones or unique ones will be the meth, eth, prop, and bute, okay? Wait, let me turn this back to the PowerPoint, guys. Awesome, but let me go back to that last slide very quickly. So as I see here, I'm looking at methane. So we wrote the molecular formula down. Molecular formulas are on this side. Then we have the condensed structural formulas, and then we have the names and the boiling points. And this is table 24.2 in your book. I see here that I have my CH4, so I have my one carbon, and we said that that will have the prefix meth. We see that, and I know it's single bonded because it ends in the ANE. If I go all the way down here to like C5, if I have 5 carbons, we said that that prefix would be pent, and I see the name is pentane. All of these carbons then must have single bonds because it ends in that ANE. There's one trend that I want to point out before we move on about alkanes. The condensed structural formula really exhibits this because we see that the carbon-hydrogen chain is getting much longer. And as the length of that chain increases, I also see what increases. The boiling point also increases. So boiling point increases with the length of the chain, and that's because the van der Waals force, which would be the only intermolecular force that's acting for a hydrocarbon, the van der Waals force, the London dispersion force, is also going to be increasing as the length of the chain and the molecular weight of each of these hydrocarbons increases, okay? So in terms of more just properties and structures of alkanes, we already said that carbons in alkanes are sp3 hybrids. They all have that tetrahedral geometry, and then the bond angle that's separating them is going to be 109.5 degrees. There's one extra thing in terms of alkanes that I want to point out. The only reason that I'm pointing this out is because oftentimes on the AP test, at least I've seen this within the last 4 or 5 years, they've brought up the term isomer, and they don't expect you to know what an isomer is, but it's really beneficial if you have that background. So I have I have 4 carbons in this structural formula, but I also have 4 carbons in this structural formula. So an isomer is something that has the same molecular formula, but they're going to be bonded in a different order. So an isomer, isomers have the same molecular formulas, but their atoms are just bonded in a different order. So I see here that for butane, I just have the carbons in a nice long chain, and they're all attached just one right after the other, so it's more consecutive. But if I look at isobutane, I have 3 carbons that are attached, and then I have this extra carbon hydrogen group that's attached to the carbon in the middle. So I can look at the structural formula, or it's probably easier just to see the condensed structural formula here. So they're the same, ultimately they're the same molecular formula, but the way that their structure is different. So these are called isomers. We'll also get into, probably later on, trans versus cis isomers, but we'll get there. So let's talk about how we would name an organic compound. There's 3 different parts to naming an organic compound. We have the base, we have the suffix, and then we could have a prefix. The base tells us how many carbons are in the longest continuous chain. So you may have these really big, beastie, bulky carbon compounds, and you're going to have to try to follow it around to find which path will lead me to have the longest carbon chain, the longest continuous chain. That's going to be the base. So ultimately, if I have 6 carbons, then my base is going to be the hex. So that tells me that I'd have 6 carbons there. The suffix is going to tell me what family it is. So the suffix tells me what type of compound. Is it single bonds? If it's single bonds, I'm going to end it with the ANE, so it's going to be an ane. So maybe I have 6 carbons, and they're all single bonded, so that's going to give me hexane. If maybe I have a double bond somewhere, and I still have the 6 carbons, I'm going to have to say that it's hexene. Okay, the prefix is going to tell us, though, what groups are attached to this particular chain. And when I say groups, I mean functional groups, and we'll also call those, what we see here by that prefix, we're also going to call those substituents. We'll get into the prefixes in a little bit. I think the next example, though, will give us a prefix so we can talk about those. But most of the prefixes that we'll talk about are functional groups, like an alcohol, which is an OH group. Okay, so for example, I have a long chain here. So my first goal is to find the longest chain in the molecule. So I could go 1, 2, 3, 4, 5, 6. So there's 6 carbons here. I could start at this one. 1, 2, 3, 4, 5, 6. We are good there. So ultimately, it doesn't really matter if you start from this CH3 or if you start from this CH3 because they're the exact same thing on either side. So we just chose to start here. Once you have determined how many carbons, I would label each one of those carbons with a number, which is what I've done for you. So this is going to be carbon 1, this is going to be carbon 2, 3, 4, 5, and 6. The reason that we're numbering them because if there's extra groups that are attached to one particular carbon, I have to name that group that's attached in terms of a prefix. So all of these are just my single carbons. So I have a really nice long carbon chain, but I do have one extra group that's attached to which carbon? It's attached to carbon number 2. So carbon number 2 has a CH3 group that's attached to it, and CH3, if you look at table 24.4, it gives us some common names of some substituent groups. So CH3 is a methyl group. It's a methyl group. So I'm going to call this, before I add the prefix, I have 1, 2, 3, 4, 5, 6 carbons, so that's going to tell me the base is hex. That's what I see here, hex. They're all single bonds, which tells me it's going to have to end in an A and E because it's an alkane. So I have hexane. That should be the easy part. But the hard part then is adding that prefix. So I'm going to designate what the actual substituent, what that extra group is. So it's methyl. We just said that it's a methyl group. CH3 is methyl. But I also have to designate what carbon is that group coming off of. And we labeled this as number 2. So because it's number 2, I'm going to call it 2-methyl hexane. Now, why did I choose to go from this end, and why didn't I start labeling here at 1 and then make this, the last one is 6? The reason that I didn't is because any of these extra substituent groups, we want them to have the lowest number carbon possible. So if I would have started here at 1, 2, 3, 4, 5, that would have been 5-methylhexane, but we want the substituent groups to have the lowest carbon number. And that's just something that we made as a rule for us, so that's the rule that we're going to follow. And that's why I started labeling this one at 1, because I saw there was an extra group there, and I know that has to have that lowest carbon number, okay? So that's just an example of how we're going to name an organic compound. Okay, same thing here. If there's more than one substituent group, we're going to name them or list them alphabetically. I think we're probably we're at about 13 minutes. So we got through just the rules of naming these organic compounds. We got through at least one example. What I want us to do on Tuesday when we come back from our fabulous 3-day weekend, I want to do a couple of the practice problems and do a lot more example problems in class of naming these organic compounds and then kind of dealing with how do I find that longest chain, what are the names of the functional groups. So we'll kind of finish that up towards the first half part of the class, and we'll work on the worksheet that I passed out with naming. Towards the latter half of the class on Tuesday, you will be starting your chromatography lab. All of the solutions have been made for you. We're ready to go on that. And on Tuesday, you'll actually be doing something for chromatography with knowns. And then on Wednesday, we're going to continue our chromatography lab, and you'll be doing some unknown sampling and testing different food dyes using different types of candy. So actually be a little food analyst with some guided inquiry activity on Wednesday. And that may lead into a little bit on Thursday, just in case we're not done. And then on Thursday, we'll kind of continue with maybe answering or fixing anything on organic chemistry on questions that we may have. But then Thursday and Friday in class will be devoted to chapter 3. Finish chapter 3 on Friday, move into chapter 4, which then sometime within that following week we'll have a test over chapters 1 through 4. And then hopefully we can get into some newer stuff instead of just all of this review. Okay, you guys have a really good weekend. I will see you guys at the football game if you were there. If not, have an awesome Labor Day weekend. See you on Tuesday. Bye-bye.